Miguel is a senior researcher at the ADAI. He's also invited professor at the University of Coimbra. He completed his PhD in 2011, specialized in natural and technology risks with focus on wildfires. He's author and co-author of several national and international scientific publications, as well as various technical reports, including those commissioned by the Portuguese Ministry of Internal Affairs related with the major wildfires in 2022 and 2023 in Portugal. Miguel, please, the screen is yours.
Well, thank you very much. Can you hear me well?
Not
Can you
so
hear
well.
me?
Can you speak a little bit louder?
Okay, now it's better?
Now it's better, now it's better.
Okay. And the other question is if my screen is in the correct presentation mode.
Yes, yes it is.
Okay, so great. So thank you very much for the introduction, and thank you very much for the invitation that was made. It is a pleasure to make this presentation. So about forest fire protection and management. So the focus will be the wildfires, and of course this management that I will talk about is much more interesting for southern countries of Europe, where that are more fire prone. Even if, as was told by Aries before, even the northern countries are now suffering, let's say, by wildfires, and so this is also very interesting for them, I believe. So, and it is crucial that at least in the southern countries, it's crucial to have in mind that fire is a natural part of the forest ecosystems, and has always been essential for the natural regeneration. Of course, that the modern forestry practices primarily involve human intervention, so cutting trees and so on, relegating fire regeneration to a secondary importance, or many times something like to be entirely eliminated. But fire is a part of our forests. And given that maybe some of you are not so familiar with wildfires propagating in forests, I will provide a brief introduction to this subject, saying that in the forest, not only in the forest actually are all the fires, but so we have three types of wildfires. The first is surface fires that are the most common type, propagating from the ground fuels, the surface fuels, through grasses or shrubs. Then we have underground fires that are developed beneath the forest's floor, and let's say that are a big challenge to extinguish them, because even after water dousings, these kind of fires persist in time as a smoldering or glowing combustion for days, weeks, many times even years, like for example in the peat fires of Indonesia and other countries. These fires are particularly significant in areas with a thick forest litter or a thick duff layer, because the tree roots are partially anchored on these layers. And so if these layers are distracted by the fires, so the fire can lead to the tree collapse, and sometimes more than the fire destruction, it's the falling of trees due to winds that are the main cause of the most damages in the tree losses. So lastly, we have the crown fires that are the most intense type of fires, and are, of course, very closely associated with forests, as they cannot occur without the presence of trees. And there are three types of crown fires. So one is the passive crown fires or torching, where only some branches or just a single tree or a small groups of trees burns, but without a sustained flame spreading through the canopy layer. Sometimes this type of fires also occur to the presence of leather fuels, such as lichens in the trunks of the trees, which can transport the fire from the surface to the tree canopy. We also have the active crown fires, or also called crowning, where the fire front progresses steadily through the tree canopy layer and supported, in this case, supported by the burning of surface fuels, also called the understory. And so this means that the active crown fires depends on the occurrence of surface fires. What is different from the independent crown fires that are similar to active crown fires, where the fire front spreads steadily in the canopy layer, but in this case without the support from the surface fires. So I would say that these fires are extremely rare. The independent crown fires are extremely rare, and I can say that the first time that I heard about these kind of fires was in the fires of Pedrógão Grande that we had in Portugal in 2017. Since then, there were some other reports on independent crown fires, like, for example, in Mati and in other extreme fires, but they are very, very rare. And anyway, what was once almost a theoretical type of crown fires has become, with the climate change and so on, has become a reality in the recent years. So given these introductory conditions regarding to the fire propagation in forest, so now I can tell, so let's say that there are two transitions of fire in the forest environment. The vertical transition, so when the fire spreads from the surface to the tree canopy, and the horizontal transition when the fire progresses from crown to crown in the canopy layer, resulting in this case in the active crown fires. Both transitions depend on the surface fire intensity and in the rate of spread, among other factors that I will talk now. So how can we reduce the vertical transition probability? So the first thing is to, sorry, because this stops working. I don't know why is not. Okay. So the first thing is to remove the surface fuels and of course reduce the intensity and the likelihood of having surface fires in the forest. However, it's important to have in mind that the existence of surface fuels are crucial for the ecosystem balance, including fauna, flora, soil erosion, and many other ecological benefits. So we cannot see a forest as totally without these surface fuels. Also, increasing the foliar moisture content. Of course, in this case, the forest manager can have little influence. The moisture content varies along the year, but somehow it can select species with a higher foliar moisture content, like, for example, the broadleaf species like oaks or chestnuts that tend to have higher foliar moisture content. Then the other is the reduction of leather fuels, which is of course not an easy task for large forested areas. And lastly, to increase the crown base height, which determines the distance between the heat source and the canopy, reducing the likelihood of crown fires. So this is something that the forest managers can do greatly to control, so with tree pruning and things like that. To reduce the horizontal fire transition between canopies, so this can be accomplished by, of course, increase the foliar moisture content, remove the surface fuels, and remove the leather fuels, as was mentioned before, but also reducing the canopy density, so separating tree canopies, so to avoid the fires to spread from one crown to the other. However, if let's say that if the forest objective is tree timber harvesting, for example, for commercial exploitation, reducing canopy density, it's important for fire risk reduction, and so to avoid losing trees. However, if this method is, let's say, that can have some disadvantages for forests with social or environmental value, that typically have a longer lifespan, because the dense canopy forests have more shadow, and consequently it reduces the surface fuels, which are the primary element to occur active crown fires, so that lead to forest destruction, except of course for the independent crown fires that do not depends on the surface fuels. Anyway, I would say that canopy density of around 75%, it's a reasonable compromise between a profitable forest and an acceptable risk for active crown fires. I show you now this work that was done by a colleague of mine, Alex Niedermeyer, on the surface fuel management, so that we saw that are so relevant to avoid forest fires or fires in the forest. And so Alex, in this project, the Fire Risk, where we are participating, so analyzed the suitability of 3 fuel management methods, namely the grazing and browsing, the prescribed burn, and the mechanical removal. So the suitability for the European territory. And so Alex found the suitability for each of these techniques and analyzed it individually, as it is presented in these slides. And additionally, she made a study to analyze the various combined techniques. For example, here you can see that in almost the entire territory of Portugal, it can be successfully implemented any of the 3 types analyzed. So these 3 techniques. This is a study that I really consider that is of great interest, and it can be, if you wish, so download it in the in the link that is provided above. Regarding to the creation of mosaics, so I remember that the fire is a natural part of the forests, and so we will always have, at least in the south, we will have always fires in the forests. So considering the interest in the forest exploitation and the planting of species that with higher profits, like for example the eucalyptus in Portugal, the strategy for reducing forest risk should involve accepting always that a portion of the forest will be lost, and mostly seeking to avoid significant losses of massive burned areas. Therefore, I would say that the best strategy is the existence of landscape forest plans that promotes the presence of heterogeneous forests managed with forest mosaics. By alternating each piece of the mosaic with more or less flammable trees and groups of trees with varying growth rates, it is possible to create a landscape that leads to a fire sectorization. This means that the fire can be confined to some slots or sectors with high susceptibility, surrounded by sectors with less susceptibility. Creation of fire breaks or discontinuity strips of fuels in the forest called fire breaks is also a technique that allows for opportunities for firefighters and perhaps to confine the fire to restricted areas. However, this type of management has some limitation, especially those related to spotting. So I will present now for those that are not so familiar with spotting. So this involves firebrands that are originated from a fire front and so can be transported by wind at great distance, sometimes of kilometers. So it's very difficult to imagine that we could create fire breaks with such dimension, and so this limits somehow the full breaks. It is important also to note that forest edges are locations where there is often a significant release of firebrands that can fall on the other side of the fire breaks, and so eventually cause new ignitions. So this phenomenon is due to horizontal vorticity, and so the creation of airflow turbulences that favors the release of this and the transport of these firebrands, and so increasing the phenomenon, the spotting. So how can we reduce this turbulence? One approach is to create physical obstacles, such as trees. So what I mean is that in those fire breaks, we should plant trees, of course, separated and let's say less flammable trees. This will create obstacles to this turbulence and also will increase the porosity of in the edge of the forest, so reducing the probability of having this turbulence and this vorticity. The other possibility is also to create a gradually decrease of the tree's height, so allowing for a smoother airflow and reducing the turbulence. Once again, of course, we should use low flammability trees and spaced appropriately. So, and what are these trees? So, in ADAI, we have conducted several experiments to address these questions. what are the less flammable trees, and what are those that do not release so many firebrands. And so one of these programs was with species typically found in the Portuguese forests, like the cork trees, quercus, eucalyptus, and pine trees. And so, as could be expected, the pine trees and the eucalyptus trees were those with more flammability. But contrarily of what could be expected, the quercus trees and the so the oak trees and the cork trees were those releasing more firebrands. They released more firebrands than the eucalyptus, for example. Of course, that I'm talking about medium distance spotting, because as we know, so the eucalyptus is very dangerous for long distance spotting. So resuming, I show this image that represents well the goal of the forest fuel management, at least what I as presented. So reducing the fire intensity, so we can have surface fuels in the forest, but in some strategical parts we should manage the surface fuels, so reduce the surface fuels, reduce the density of the trees in order of having this intensity, so a decrease of the intensity and even an extinguishment of the fire, or at least creating opportunities for firefighting. Normally, when I train firefighters, I used to show these two images just to tell them, just to ask them, what is for you more dangerous, the left figure or the right figure? The image, normally they say the left one, but I would say that in the forest fires, or the fires in the forest, I would say that the most dangerous is the right figure, because as you can see, nobody will try to fight a fire, for example, in the left figure, because it's very scaring. But as you can see in this video that I took from the internet, so in this case we have something like in the left figure, in the right figure, the right image, and you can see so how fast a surface fire in the forest can pass to an active ground fire. So we are talking, this is in about 30 seconds or something like that, a surface fire in a forest, in a dense forest, with so not managed, as I told before, so can become entirely immersed in flames. And so that's all. Thank you very much.